Let h of x equal 2x minus 9 times x minus 1 times x plus 4 over x minus 3 times x plus 1 times x plus 4. And it says find the following, then graph the function. So we're basically doing what we did before, except this time it's in factored form for us. So the first thing that we should do is see if we have any holes. And it looks like we do at -4. So we can find our y coordinate by plugging in -4. So you get 2 times -4 minus 9 times -4 minus 1 over -4 minus 3 times -4 plus 1. And we get -8 minus 9 is -17 times -5 over -7 times -3, which is 85 over 21, which is 4.05 something something something. Okay, so let's just keep it as 85 over 21. So now we found our whole. So let's find our zeros. So that's in our numerator. So we have a 2x minus 9 is equal to 0. So you have x is equal to 9 over 2. And we have an x is equal to 1. Okay, now our y-intercept, we plug in 0 into our x. So you get 2 times 0 minus 9 times 0 minus 1 over 0 minus 3 times 0 plus 1. And we could plug it into our whole as well, right? But these two will ultimately divide out. So you get 2 times 0 minus 9, so you get, move this down. Okay, so you get -9 times -1 over -3 times +1, and you get 9 over -3, which is -3. So we have 0, comma, -3. Vertical asymptotes are in our denominator. So we have x equals to 3 and x equals to -1. And we found our whole and our horizontal asymptote. So I'm gonna take out this 2 here. So we have x minus 4.5. So if we were to multiply all of our numerator together, we would get something like 2x to the third, blah, blah, blah. And on the bottom, we would get another x third, blah, blah, blah. So when we have the same degree, that means we use the ratio of the coefficients. So our horizontal asymptote is going to be at y equals 2. So let's sketch our function now. Okay, so we have a 0 at 9 over 2, which is 4.5. So about here. Oh, that's -4.5. So here, 9 over 2. And then we have another one at 1, 0. We have a y-intercept at -3. We have vertical asymptotes at 3 and -1. We have a whole at -4 and 85 over 21. Remember we said it was 4 point something. So 1, 2, 3, 4. Here's 4. 4 point something, so possibly somewhere around here. And we have a horizontal asymptote at 2. So our graph is going to look something like this. Use the tables to replace the question marks in each limit statement. So we're going to look at the limit as x approaches 13,000. So when it's coming from the left side, it's approaching 2.9975. And as it's coming from the right side, it's also approaching 2.9975, which we can round up to 3. And for B, we're looking at the limit as x approaches -5. So coming from the left side, it approaches 13.996. And coming from the right side, it's approaching 14.004, which both round to about 14. Even though the limit at the value at -5 is an error, which probably means there's an asymptote there or there's a hole there, but our limit is 14. And it says, write a rational function that has the following characteristics. Zeros at 6 and -2. So we know that our zeros are in our numerator. So we have x minus 6 and x plus 2. And then we have vertical asymptotes at x equals 1 and x equals -4. So we know that goes on our denominator. So we have x minus 1 and x plus 4. And then we have a horizontal asymptote at -3. So actually, let's do the hole first. So we have a hole when x is -7, which means that we need an x plus 7 on the top and the bottom. So if we were to multiply all of this out, we would get an x cubed over an x cubed, which means that we're going to have the ratio of the coefficients as our horizontal asymptote. And since our horizontal asymptote is -3, you can just put a -3 there. And I could also put like -3 over 3, or -9 over 3. I could put -27 over 9, right? I could do anything as long as my horizontal asymptote is still -3. And it says, write a possible function for the graph below. Just a little bit bigger. Okay, so let's see what we have here. We have an x-intercept at 6, 0. We have a horizontal asymptote at y equals 3. We have a vertical asymptote at x equals 3. And we have a hole at -4. It's a little bit over 4, so. But we know that it's at -4, comma, let's say it's like 4.2. So, now that we found all our components here, we know that our x-intercept goes on the top. So you have x minus 6. Our vertical asymptote goes on the bottom. So you have x minus 3. You have a hole at -4, so x plus 4 and x plus 4 needs to be on top and bottom. And our horizontal asymptote, so if we were to expand these out, we would get an x squared on top and an x squared on the bottom as our highest degree. And since they're the same, we're going to use the ratio of the coefficients. So we want our ratio to be 3, so we can just stick a 3 here. Again, you can do 27 over 9, 9 over 3, as long as that you get 3 as your ratio. And just to check, if we were to plug in -4, our whole, let's say if we'll get 4.2. So you get 3 times -4 minus 6 over -4 minus 3, which is 3 times -10 over -7, -30 over -7. Do that in the calculator, and you get 4.28 something something. So it matches. So this equation right here is correct. And our last page. So we have evaluate the following, and we have a bunch of limits with the same function. So the first thing we can do is make a graph. Let's make a graph, and that'll make it easier to find these limits. So it looks like we have a hole at -3. And let's plug in -3 to find our y value. And we get 4 times 2 over -4, which is 8 over -4, which is -2. So that's where our hole is. Our x-intercept is going to be at -5. And we have a vertical asymptote at x equals 1. And our horizontal asymptote is going to be, when you expand this out, you get an x squared on top, an x squared on the bottom for our highest degrees. And so our horizontal asymptote will be the ratio of the coefficients. And since we have a 4 on top, our horizontal asymptote is going to be at 4. And let's also find our y-intercept, so we know what our graph looks like. So our y-intercept, you plug in 0 for x, so you get 4 times 0 plus 5, which is 5, 0 plus 3, which is 3, over 0 minus 1, which is -1, and 0 plus 3, which is again 3. These divide out, and you get 20 over -1, which is just -20. So our y-intercept is at 0, -20. So let's see what our graph is going to look like. So we have 0, -20. Let's put that down there. We have a hole at -3, -2. We have an x-intercept at -5. We have a vertical asymptote at 1. The horizontal asymptote at 4. Okay, so which tells us that our graph is going to look like this. Okay, so now let's find our limits. So you have the limit as x approaches positive infinity, f of x approaches what? So as x is approaching positive infinity, our f of x here is approaching 4. And we have the limit as x is approaching 0 from, so remember that when it doesn't have the superscript, a plus or a minus sign, we have to look at both the left hand and the right hand limits. So coming from the left side, we have the limit is x approaching 0 from the left side, f of x approaches -20. And coming from the right side, we again get -20. So when our left hand and right hand limit are the same, our limit is at that value. So it's -20. And the limit as x approaches 1, so that's at our vertical asymptote here. So I'm just going to redraw my graph. There's too many colors here. Oops, my hole is gone. Okay, right there. And the limit as x approaches 1, so 1 from the left, it's approaching -infinity. And 1 from the right, it's approaching positive infinity, which means that my limit does not exist. And our last one here, the limit as x approaches -3, so we have to look at the left and the right side. So as it's coming toward -3 from the left side, we stop at -2. And as it's coming from the right side, again we stop at -2, which tells us that our limit as x approaches -3 is -2.